Hi, and welcome to day 10 of polynomials. And today we're going to talk about the special rule of zero in factoring. And what it just means is we're going to be setting our expressions equal to 0 instead of just leaving them as expressions. So find all the solutions to the equation, the quantity x squared minus 5 or plus 5x plus 6 times the quantity x squared minus 3x minus 4 equals 0. And I'm going to break these down into two separate polynomials that I factor. And you may not remember factoring, but I'm going to go through it, and we will continue to work with it for the rest of this unit and even into the next unit. So hopefully by then you'll pick it up. So I'm going to look at what are my factors of 6 that when I add them, I get 5. So that would be x and x, 2 and 3. And since my last sign is positive, my signs are the same. Take the sign in the middle, which is positive, so it's plus and plus. And my factors of 4 that subtract to give me 3 are 4 and 1. And so that would be a minus 4 and a plus 1 because the larger number takes the sign in the middle, which happens to be negative. And that is equal to 0. So then I can take each factor and set it equal to 0. So if I were to solve this equation, I get x equals negative 2. This one would be x equals negative 3. Next one would be x equals positive 4. And x equals negative 1. So find the solutions. Well, of the quantity x squared minus 9 times the quantity x squared minus 16. This goes back to yesterday's lesson where we were talking about the difference of two perfect squares and them being conjugate pairs and the good twin and the bad twin, all that fun stuff. So just remember, break them up into its two parts. The first one is x plus 3, x minus 3, and this would be x plus 4, x minus 4. Equals 0, then we would go through and do the same thing, but I don't actually have to show that step. I can just say x equals negative 3, x equals 3, x equals negative 4, x equals 4. So technically x equals plus or minus 3, and x equals plus or minus 4. Suppose we know that the polynomial equation 4x cubed minus 12x squared plus 3x plus 5 equals 0 has 3 real solutions, and that one of the factors of that polynomial is x minus 1. How can we find all 3 solutions to the given equation? Well, the first thing I can do is divide. I can use long division, I can use reverse tabular, or I can use synthetic. And this case because it's linear, and I'm going to use synthetic because it's faster at this point. So instead of using negative 1, remember we always have to change this one to its opposite. So it's 1 on the outside, and then on the inside it's 4, negative 12, 3, and 5. Bring down your 4. 1 times 4 is 4. Negative 12 and 4 is negative 8. 1 times negative 8 is negative 8. 3 and negative 8 is negative 5. 1 times negative 5 is negative 5. And that zeroes out. So that means, so far, we have x minus 1 as a factor, for sure. And we have 4x squared minus 8x minus 5 is my other factor. And I need to break that down even further. And to do that, I need to say 4 times negative 5 is negative 20. And I'm going to do factor by grouping. Some of you may have never seen this before. Some of you may have seen it before. We will continue to work with it, so don't worry. My factors that are negative 20 are 1 and negative 20. Negative 1 and 20. Negative 2 and 10. Negative 4 and 5. 4 and negative 5. And then 2 and negative 10. And then 1 and negative 20. And now I need to look for the pair that adds up to negative 8x squared, which is 2 and negative 10. So I'm just going to write this out as 4x squared plus 2x minus 10x minus 5 equals 0. And remember when we did the Punnett square things, the box method, and we have our 4 squares here? This is diagonal is where our like terms come in our quadratics. This is our squared term over here, and this is just our coefficient over there. Well, so the 4x squared would be up in this box here, the negative 5 would be in this box here, and then one of these would be 2x, and one of these would be negative 10x. So what I've done is we've uncombined the middle terms. So now what I want to do is group them in 2 and 2 and look for a common factor. So 4x squared plus 2x has a 2x in common, and when I divide that out, I get 2x plus 1. And negative 10x and negative 5x have a negative 5 in common, so I'm left with 2x plus 1. Now notice that my parentheses are exactly the same, so that means that one of my common factors is 2x plus 1, and then what's left over is the 2x minus 5. So that's my other factor. So that's going to be 2x plus 1 and 2x minus 5 equals 0. So now I need to keep working with this and set each one equal to 0. So x minus 1 equals 0, 2x plus 1 equals 0, 2x minus 5 equals 0. So, sure you know together. X equals 1. Here I'm going to subtract 1. So 2x minus equals negative 1 divided by 2. So x equals negative 1/2. And then 2x, I'm going to add the 5, equals 5. Divide both sides by 2. So x equals 5/2. So my 3 zeros, or my solutions, are x equals 1, 5/2, and negative 1/2. So these are my 3 solutions. We talk about zeros, we talk about roots, we talk about solutions. All 3 of those words mean exactly the same thing. All right, next page. Find the zeros of the following polynomial functions with their multiplicities. Multiplicity means you get the same root more than once. Okay, so anything that has an exponent has some kind of multiplicity. So in this case here, I know that x equals negative 1 is going to be one of my roots, and I know that x equals 1 is going to be one of my roots, but I'm not really sure when I have x squared plus 1 what will happen. So if I set that one equal to 0, and I say x squared equals, if I go to solve that, I'm going to subtract 1, negative 1. The problem is I can't find a number that when I multiply it by itself, I get negative 1. So this is not factorable. So it has no real roots. So my only real roots are just going to be x equals negative 1 and x equals 1. For B, x minus 4 to the third, x minus 2 to the eighth, well, that means that x equals 4, and I have a multiplicity of 3. And here I have x equals 2 with a multiplicity of 8. So what happens is I set the inside equal to 0. So x minus 4 equals 0. And I solve that, so I get x equals 4. And I do the same thing with x minus 2. And the exponent means we have that same little linear factor 3 times or 8 times. So that's your multiplicity. So for the next one, if I have 2x minus 3 equals 0, and I go to solve that, I will have 2x equals 3 divided by 2, x equals 3/2 with a multiplicity of 5. And this one here, 3x plus 4 equals 0. So 3x equals negative 4. Divide by 3. So x equals negative 4/3 with multiplicity 100. And the other side is x equals 17 with multiplicity 4. For number 3, find the polynomial function that has the following zeros and multiplicities. What is the degree of your polynomial? Well, what we're going to do is kind of go backwards. Since we have the 0, so that means that x equals 2. If I were to set that equal to 0 or get it equal to 0, I'd have to subtract 2 from both sides. So x equals, sorry, I didn't want to write that. So it's just x minus 2 equals 0. So those are my factors where 2 is my 0. And since I'm trying to find a polynomial function, I need to say f of x equals. Well, if my 0 is 2, that means my factor is x minus 2. My multiplicity is 3, so the exponent is 3. If negative 4 is my 0, that means x plus 4 is my factor, and its multiplicity of 1, so I don't have to do anything. So the next one's x minus 6 with a multiplicity of 6. The next one is x plus 8 with multiplicity of 10. Is there more than one polynomial function that has the same zeros and multiplicities as the one you found in exercise 3? Yes. Oh, I forgot to answer. Sorry. What is my degree of my polynomial? If I have 3 and 1, I get 4 plus 6 is 10 plus 10 is 20. So this is a 20th degree. So we already read this one. Is there another one that's the same? And the answer is yes. I can always find multiple polynomial functions that have the same multiplicities and same roots but look different. So everything is going to be the same as I already have. But if you remember from that problem, oops, minus 2, not 3, multiplicity of 3. If you remember that problem we had in the beginning that was not factorable, that x squared minus or plus 1 was not factorable, I can multiply by a factor that is not factorable, and I have not changed the roots, how many roots I have. The only thing that changes is the degree. Because I multiplied by an x squared, I have to add 2 more. So I have a 22nd degree. And it says, can you find a rule that relates the multiplicities of the zeros to the degree of the polynomial function? The answer to that is yes again. The sum of the multiplicities of all zeros is greater than or equal to the degree of the polynomial when the factors are linear or not. If the factors are all linear, then the sum of the multiplicity I'm just going to abbreviate multiplicity to mult, is equal to the degree of the polynomial. I'm just going to abbreviate that poly. All right, so that is it for this set of notes. The multiplicity idea is new to you, but that is very helpful information to know.